Hello, boys and girls. Last session we have found out that we need to make this RPM measurement timed, that we want to return an RPM value only once a second or something like that. So that's why we will need timer-based interrupts, and that's not such a trivial thing to do. So I'll have to first read up on these. I have started reading this article. This is the list of interrupts in the Arduino Uno. Arduino Mega might have some other interrupts too. And there is a timer, and these three seems to be the timer interrupts. And these three we need to learn to use. Status register. I don't know this variable type. Byte stores 8-bit unsigned. Basically the same. Writers of embedded software often define these types because system can sometimes define integer to 8 bits, 16 bits. She doesn't arise, but size of basically defined as a language unsigned char. The byte data type is to be preferred. What's the difference? Yeah, but what does the T mean? It is a type name as opposed to a variable name. Okay. 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 Unsigned integer 8 type. Okay. Hello, Falco. Welcome. Disable interrupt. function names. What are AVR processes? Starkey is asking, enjoying the Arduino stuff. I'm going to the same things for school at the moment. Ah, you're happy. Yeah. This tells the compiler such variables might change at any time. The compiler must reload the variable when it is reference rather than relying copy my. You know, there are two functions by which you attach interrupts in Arduino. One is attach interrupt, and the other is ISR. I was actually started reading this thing because we need a timer for our RPM meter, and he goes quite really to low-level interrupt programming, and he's got some processor internal variables here, and instead of attach interrupt, he is using this thing, this ISR function. And somehow this ISR function doesn't really even return anything. So this is where I stopped and said, okay, maybe I should Google what's the difference between ISR and attach interrupt. Why doesn't he attach an interrupt here? And they just pointed me to this article. So here's a volatile character buffer and byte position. And now you see here he is using ISR function. SPI STC vector. Yeah, it would be good to know what SPI is. And what is SPI data register? Okay, looks like this interrupt routine serves the purpose that it saves the byte from the SPI data register to a buffer. In this case, you use the ISR define and supply the name of the relevant vector. In this case, ISR is handling an SPI transfer completing. Note some old code uses signal instead of ISR. Signal is deprecated, yeah. Connecting an ISR to interrupt. Configuring the processor to handle an interrupt. The next step, once you have an ISR, is to tell the processor that you want this particular condition to raise an interrupt. For example, as an example, for external interrupt 0, you could do something like this. External interrupt, blah, blah, blah. Clear existing flags, set wanted flags, enable it. Tilde operator is bitwise not. It inverts the bits in a binary number. Okay. Yeah, he uses that a lot. Yeah. So whatever. So this is the interrupt control register, external interrupt control register A, external interrupt mask register, and flag register. Okay, so what he does here, he clear existing flags. So he wants to I don't know what SC, what ISC means. But you probably have it here. No, we don't have it in ISC. Okay, what the hell is ISC? I just would very much like to know what does ISC stand for. But basically, this is some flag settings. External interrupt mask. External interrupt control register. Okay, he sets basically some interrupts with this. A more readable would be, yeah. Would be set according to this table data sheet. At mega data sheet. Doesn't look like it has a page 71. So the low level of interrupt 0 generates an interrupt request. Any logical change? That's the change interrupt. Oh yeah, that's basically the interrupt we want. So here we choose the interrupt what we want, whether we want interrupt control register, whether we want 0 0, which would be we want to interrupt when it has a low state, or we want an interrupt if it's being changed, or we want an interrupt if it's falling or if it's raising. That would be 3. This is 0 1 2 3. So that's why he says 3, clear existing flags, because not 3 bitwise is 0 0. So he actually, no, why not clear? Still don't understand. Generates. Whatever. ISC. Don't they? If icarnas or 2, after we have cleared flags, then or 2 means or 2 would be this falling edge. Falling level interrupt, and enable interrupt mask. He sets to or 1, which means either off or on. I still don't know how this mask works. Set the flag. He doesn't use the flags. And why does? Probably if this 0th bit is 1, maybe it's enabled then. Okay. There is, I know, I start to understand there is an external interrupt 0 and external interrupt 1. That's what we have said here. There is external interrupt on the Arduino. There is external interrupt 1 and external interrupt 0. And with this mask, you set to which interrupts you want to listen. If you have a 1 here, it will listen to external interrupt 2. If you have a 1 here, it will listen to external interrupt 0. And here, in this control register, you say whether you want. You have control register A. You also have control register B, I guess. Whether you want to listen whether it's low, change, falling, or rising. Low, change, falling or rising, which means you can't really tell it, listen when it's high. Whatever. Yeah, okay. Low level ISRs versus library ISRs. To simplify your life, some common interrupt handlers are actually inside the library code. For example, interrupt 0 vector and interrupt 1 vector are inside the library code, and then a more user-friendly interface is provided. That's the attach interrupt. What attach interrupt actually does is save the address of your wanted interrupt handler into a variable. What is an interrupt handler and why does it have an address? Save the address of your wanted interrupt handler into a variable. Well, interrupt handler could be something like external interrupt 0 or external interrupt 1. Let's say that's an interrupt handler. And each interrupt handler has an address, I guess. Is that true? And then call that from int0 vector or int1 vector when needed. Or maybe interrupt handler is the event when either interrupt 1 or interrupt 0 reach low, change, falling or rising. Maybe that is an interrupt handler. You say interrupt handler is the function you want to run when the interrupt is triggered. Okay, I get it. Thank you. So interrupt handler would be something like this. This would be our interrupt handler, okay? And this function would be our interrupt handler, and when the code is compiled, it has some address, some memory address or whatever. And what attach interrupt actually does is to save the address of your wanted interrupt into a variable and then call that from. I still didn't understand what is int0 vector, and it's int0 vector. If it even stands for vector, I don't know what vect is, but what else could it be? So int0 vector, but the ISR function is a general interrupt service routine for all interrupts. For all interrupts, it means that you can have several ISR functions in an. Okay, yeah, that's good. The argument int0 vector indicate that the ISR is for the external interrupt 0, and vect is just a name. Like I have unsigned integer 8t, and the t stands for typed. Maybe vect says something for, yeah, that very, I'm pointing to that interrupt. I mean that interrupt. So this is actually, so instead of attach interrupt, digital pin to interrupt, call a routine and falling edge, then we could say this. But how do you, if you do it this way, how do you define when you want to be interrupted, whether you want to be interrupted on low, change? Because if we use this attach interrupt, by digital pin to interrupt, it translates the pin number to the interrupt. Let's say it's external interrupt 0. Here we call our interrupt handler, and here we call the third argument is when do we want to be interrupted, and when this handler has to be run, and that's on change and falling, rising. And if we do it with this ISR function, we do this with the ISR function, how do we define whether we want to be interrupted on low, on change, on falling, or rising? You see, if I do it like this, how do I say it should only react when the signal is rising, for example? I guess that's what's defined here in this external interrupt control register, and it has to be said separately. But somehow makes little sense. Well, Starkey says probably stands for vector. It's vector beyond me, maybe because it's all the vector of addresses. Yeah, with the X. Yeah. Okay. You see, but you still understand that this. I understand this. This is maybe what to do when it's interrupt. But how do you define? How do you make it only on falling, rising, or low, change? How can he even define it via ISR function and not care about whether it will be on change, on low, on whatever? Because if you define an interrupt with attach interrupt, you generally care about the kind of change or the kind of signal level you want to be interrupted at. But if you define it via ISR function, it seems you don't care about when. Well, that's what puzzles me. Yeah, interrupt handler, also known as interrupt service routine. Good. The mask register actually enables the interrupt. Yes, I understand that. Fortunately, you don't need to remember those numbers because attach interrupt does that for you. However, that is what is actually happening. That is what is actually happening. And for other interrupts, you may have to manually set interrupt flags. Okay. So now he discusses low-level ISRs with library ISR. To simplify your life, common interrupt handlers are actually inside the library code. For example, external interrupt 0 and external interrupt 1. And then more user-friendly, we call that, what an interrupt actually does, whatever, then call from vector needed. It also sets up appropriate register flags. So yeah, it sets the register flags. I guess that's exactly these flags, whether we want rising, falling, changing, low. That's what the attach interrupt does for us, while our ISR does not. Can ISRs be interrupted? In short, no, not unless you want them to be. As entered, interrupts are disabled. Naturally, then must be enabled. Yes, it does automatically. However, you can turn interrupts on inside it. You absolutely must. Yeah, on pin change, handle pin change, allow more interrupts. Normally, you would need a pretty good reason to do this, as another interrupt now could result in a recursive call to pin change, which with quite possibly undesirable results. Yeah. Good. How long does it take to execute an ISR? According to the datasheet, the minimum amount of time of service to service an interrupt is 4 clock cycles. To push the current push the current program counter onto the stack. I have no idea what this means. What is a program counter? I know what a stack is, but in this context, I have no idea. Is there a program stack? Counter stack, or what stack? It's 4 clock cycles followed by the code now executing at the interrupt vector location. This normally contains a jump to where the interrupt routine really is, which is another 3 cycles. Yeah. Starkey says, if you have access to the registers, you can use the attach interrupt function and print the values of the registers to confirm that it looks like what it looks like at the low level. Yeah, we totally could do that. I understand so much, so that much. Then an ISR is declared with us and does something like this. Okay. SPI, so this is some serial. What was SPI again? Serial peripheral interface. SPI STC. Damn, what is STC? Short. The hell is STC? Isn't it stack or something? It would be STK. Stack would be STK. Interrupts. Whatever, don't care about it. Whatever STC is. So, and this looks like the actual machine code of Arduino here. Starkey says what they are referring to is the time it takes for the context switch change from one active process to another. An interrupt is going to halt your process, execute the handler, and then resume it. Yes, I understand that. This process stopping 4 cycles. Yes. Yes, Ferko, the RPM meter is related to the Arduino Tapper project because I need to figure out a suitable translation ratio of the DC motor. It rotates too fast. I can't have the axle tapping or moving the tappers rotate that fast as the motor rotates. The motor has to translate to a slower rotation, which has also more torque than the fast rotation of the DC motor. And I need to find a suitable translation ratio. But for that, I need to first know how fast does the motor rotate and roughly how fast I want my axle to rotate, and then I can figure out the transmission ratio. So this is all relevant to the Arduino, to the Tapper project. Yeah. So whatever it saves. I don't know what. And this looks like a vector of That's another 16 cycles in brackets. Yeah, whatever. This does something with the SPI communication. How can he count cycles? He counts cycles like it would be obvious that this is 16 cycles, this is 3 cycles, this is 4 cycles. How can he know? He's a guru. To leave the ISR, we have this routine. Okay, so this is probably the routine to enter the ISR. So it saves something. sreg, it saves the sreg, the status of the processor before the interrupt, and then it pushes some other, and then it does the register, and then it pushes some other, it pushes the same in the opposite sequence order, pushes the registers in opposite sequence, and it resumes the old status register, and then it probably says, maybe this is something like save the information that the interrupt has been called, yeah, save the status, and I don't know, halt the process, and then resume the process, and clear the memory that the interrupt is no longer actively running or something. I don't know what this means. What is R0 register? Whatever. I don't need to know everything. Feko says, can't you just activate the motor back and forward there? No idea what that should help. Motor back and forward. Oh, you mean like not having the motor rotating in one direction, but having rotate that and rotate then. Basically make it a servo. Use a DC motor instead of a servo. No, I don't think it's not good for a DC motor to change rotation direction so quickly. It's not built to do that. If you mean that. Oh, hello, Minipack. Yeah, but I'm no longer gaming. Not gaming right now. I'm just learning some electronics stuff. Oh, and when you, however, the external interrupts. Okay, this was an SPI interrupt, and the external interrupt do quite a bit more things here. Yeah, whatever. It takes 82 cycles here. Whatever. Run motor for split with reverse polarity. Yeah, that's making it a servo. That's why I have servos for, and even I had this servo running and moving like 1 or 2 millimeters, back and forth, and then I realized that the servo is getting really hot, and I was observing these little cogs inside the servo and said, okay, these cogs were built for like, I don't know, 10,000 uses or whatever. And if I'd have the tapper running whole day, the lifetime of these servos would be gone in no time. I mean, I could change the servo every week because it would be just going back and forth 24/7. You know, they are not built to do that. The servos are built to move a little and then pause for a longer time. Move a little, pause. You know, it's not like you could do that. But a DC motor, once it runs, that's the whole idea, that I want to have a DC motor running all the time. That's why I'm doing the thing with the axles and those arms tapping. That's the whole idea. I could have used servos, of course, but I think that would be much easier using servos all the way, even for the 10 grinding tappers. So yeah, but their lifetime would be very much reduced. So I want to use a motor-driven hammer-like tapping for the grinding tappers, and I will use servos for the tappings where you need to, I don't know, close the ad just and refresh a worker. If a worker works only for 1 minute 30 seconds, then every 1 minute 30 seconds you have to reassign him work. So for these things I would use servos. So that's what I wanted to do. Performance considerations. Interrupts can increase performance messages because you can get on with the main work of your program without having constantly testing if switches exactly. Having said that, the overhead of servicing an interrupt as described above would actually be more than doing a tight loop, polling a single input port. If you absolutely need to respond to an event within, say, a microsecond, then an interrupt would be too slow. In that case, you might disable interrupts and just loop looking for the pin to change. How are interrupts queued? Oh boy, oh boy, oh boy, I don't want to know that. Hence from writing ISRs. Keep them short, reasonable to single byte flag, and test that flag in the main loop function. Okay. Disabled. Interrupts are disabled, thus obtaining a millisecond function. The time returned by a millisecond function call would lead to a disappointment. It is valid to obtain the time that way. Since interrupts are disabled inside an ISR, and since the latest version of the Arduino IDE uses interrupts for serial reading and writing and also incrementing the counter, you should not attempt to use those functions inside an interrupt. Yeah. You can get the time from a call to millis, however, it won't increment. So don't attempt to delay waiting for it. Don't do serial prints. Don't try to do serial reading. Pin change interrupts. There are two ways you can detect external events on pins. External interrupt. These general discrete input levels 1 per pin. You can get to those by using attach interrupt for each pin. You can specify raising, falling, changing level. However, there are also pin change interrupts for all pins. These act on a group of pins. They're also low priority. You could make an interrupt handler to handle changes on pins like this. Pin change interrupt vector and okay, pin change interrupt, pin change interrupt, okay. Yeah. 8, 9, 10, 11, 12, 13, 6. Okay. Clearly extra code is needed to work out exactly which pin change interrupts have associated mask. You can actually configure them only react to say blah 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 rather than a change to, yeah. However, you still need to work out which of these changed. Okay. Example, watchdog timer interrupt. Yeah, screen clicker. What do you have? Yes, this is nice. Yes, such a screen clicker. Yeah, these pistons, I see. Oh, this is cool. Yeah, well, I'm not using pistons like this. But this is ingenious. Ingenious. I love it. Ah, wonderful. Yes, yes. Exactly. Wonderful. Ah, beautiful. Ah, no, there is no pistons like that. Certainly, it would be possible. I just sort of bought my equipment to do the hammer like water wheel like tapping. So I will not change my concept now. No, Ferko, not only one piston. I want several pistons. Like I want at least 8 pistons, because when I click manually, I use 8 fingers to cover all the street in the display of the beggar, because on those positions I gather the money bags and the big coins they are throwing me. If I would have these piston, I would have only 1 or 2 places where the pistons tap, and they would never pick up a big bag thrown somewhere else, or even the most precious are actually these credit cards they throw you, and these credit cards get thrown all over the place, and I would love to pick every single one of them. So that's why I need a spread of these touching pens all over the road, basically, or pretty equally. Probably I will not have 100% coverage, but I want to have at least like 70-80% coverage of the road area where the coins fall, you know. And for this, the hammering layout is slightly better to set up, because you have to get the timing right. You don't want to have a simultaneous tap on this, because then it would be interpolated and it will only send one tap in the middle. So I really want them sequenced in this sort of way, you know. And it's very hard to do with these. It's much harder to set up and time with these piston-like setups. Oh, okay, executing. Timer interrupts. Okay, so we have timer interrupts. So we know there is timer 0, 1, and can't we actually get an Arduino Mega 2560 data sheet? We should save this. and we should save Atmel mega data sheet. Yeah, this is the real stuff. This is the real stuff. So here we know everything about the Atmel Mega. So here we can see the interrupts and timers and whatever. But I think it has also only 3 timers. (128 kilohertz internal oscillator). Wow, it runs at 128. No, wait, kilohertz is too slow. Can't be. What does it mean? The RC oscillator. Oh, those are clock sources. System clock and clock options. CPU clock. CPU clock is routed to parts of the system over core. Examples: modules, general purpose register, status register, data memory holding, stack pointer halting. There is input-output clock used by majority on input-output timer counters, SPI, OART, USART. Input-output is external interrupt module, but note that some external interrupts are detected by asynchronous logic, such as interrupts objective to iCloud. Okay, so I guess it's IO clock. What is the timer we are using? There's a flash clock, asynchronous clock, ADC clock. I have no idea what this is. Clock select. Okay, so which one is the IO clock? Default clock source, clock startup sequence. You have many kits. Is there perhaps some exercise in one of them? Of course, on almost everyone is an exercise. Well, actually, I have only one kit with an exercise, and I don't really like these exercises as much as this Sunfounder. But it's a manual. I have a Sunfounder kit version 2, and this is manual to Sunfounder kit version 1, so it doesn't cover all what's possible with this kit, you know. Yeah, so bleh. And it doesn't really go into depth much. These are some interrupt sources. I don't know what are these ports they are talking about. Interrupts, haha. Here we go. This is the list of interrupts in the Arduino Mega. But an exercise to something similar you are trying to do. No, Ferko, I have looked. There is nothing like timer interrupts exercise. There's nothing like timer interrupt exercise. Not in here. It's on the web. I mean, I'm already using it. I'm already where I need to be. Wow, it has 8 external interrupts. Compare that to 2 external interrupts of the Arduino Uno. Wow, that's good. And it has, wow, so many interrupts. Ooh, good. Interrupt vector placement. It's really vector. Interrupt vectors. They really... You know what is an... Interrupt vectors. What are interrupt vectors? Maybe I should first... What is an interrupt vector? Interrupt vector table is a data structure that associates a list of interrupt handlers with interrupt requests. With interrupt requests in the table of interrupt vectors. Each entry of the interrupt vector table is called an interrupt vector. Each entry is an interrupt vector. Is the address of an interrupt handler. Each line is an address of an interrupt handler. Okay, so these are the addresses of interrupt handlers. Is that true? The arrows indicate increasing addresses. Each entry, maybe intermittent background. Most processors do have an interrupt vector table, including Atmel. Yeah. Interrupt acknowledge. Predefined method loads the program counter directly with the address. The jump table itself contains executable code. It's called at each entry is a single jump. Use the predefined approach. Yeah, whatever. Let's do not go into that much detail. Let's stay on track. Stay on track with so, because you know, the problem here is that normally you use interrupts only on pins. But here we want a special interrupt, namely by timer. I want the program to do nothing except once a second see what happened in the last second, how many propeller blade passes it registered, and how, yeah, basically how many propeller passes it registered, and then it should calculate the RPM from it. And it should do that only every second. It should collect those propeller blade passes and count them, and once every second it should calculate an RPM of it, and then put it out on the display. That's why I need a timer interrupt. I mean, I could easily do all that. I could easily do all that by saying in the main loop something like if millisecond I don't know how is it. I just write mod 1000 equals 0. If I find a function for modulo division, so every full second, every whole second, it should do this, you know. Maybe it's probably it's easier. I mean, I could write that, and it would work. It would work. But I could as well learn how to do a timer interrupt at this point. Unsigned long int now millisecond. You can, okay. The normal Arduino uses a timer 0 to provide a clock, being a number that is incremented and adjusted to give you a count per millisecond. You can read that by doing something like this. Yeah. You can find a more accurate timer value by microseconds, which takes the current value from a millisecond counter and adds in the current reading from timer 0, thus correcting for right now. However, you can make your own interrupts, say using timer 1 instead of timer 0, like this. ISR. So now I'm at a loss. This is the vector to the timer 1 interrupt. So we have a timer counter compare A, timer counter compare 8. So this is timer 1 compare 8. Okay, it is this timer. Timer counter compare A. Okay. We want to attach a service routine to that. Static boolean state false. State is not state, toggle. And then it would write something, whatever. So you plan to use 8 little DC motors to actuate hammers? Actually, I wanted to use only 1 or 2. Maybe, yeah, one or two. 1 or 2, maybe 3. 3 DC motors. I would have 2 motors, 1 or 2 motors actuating the hammers to gather the coins on the road, and 1 DC motor to actuate hammers popping the balloons. Now maybe it will have to be 2 motors there, but I don't know. Time will show. So digital write, LED state. Yeah, this is some syntactic sugar, but it means digital write LED. If state is true, then write high, else low or something. I hate that when people use it. I mean, it looks nice, it's very short, but people who are not familiar with the programming language, it's totally incomprehensible. Yeah, this is exactly that. Variable equals statement, return value if true, return value if false. Yeah. Basically, it should be this. Yeah, but it's fine. I mean, I can live with that. State high low. State if high if low. Okay, so that's our timer interrupt. Static boolean false. Void setup, pin mode. Okay, set up timer 1. Here we set up timer 1. TCCR1. What is TCCR1? Timer counter compare register 1. Yeah, this is the address of timer counter control register. Yeah, so basically normal operation. It doesn't do anything, right? Or what? TCCR. What is that? WGM bit CS10. Damn you. You have comments, but they are not helping. This uses a clear timer on compare, so it counts up to the specified value. Okay. Clears the timer. So it has cleared timer, is it not? and starts again. Compare a register value 1000 times clock speed. I have no idea. This toggles pin D13 faster than you can see once every. It turns on every second toggle. That is every. Giving a frequency of. The counter is 0 relative. What does it mean? So if the counter is 1, then it actually counts 2 times the clock speed per prescaler. So for an interval of 1000, you need 1000 times slower than you need. No idea. If you change the prescaler, milliseconds. And even more simply, you can output a timer result without in constant binary. Timer bait toggle on compare match. Exactly. I have seen an example code suggesting you count things for a second by turning interrupts off for a second. What? And then, oh, no. Event ISR, events increase. With setup suitably attach digital pin to event ISR, falling, event 0, reset counter, interrupts, delay. Oh, okay. That may work for simple, but turning interrupts off means it won't work until they. Better to use millis. Counting, start time, unsigned interval, 1 second. Yeah, this is probably what we need here. So we have a counting thing, events ++ with setup, print line, attach interrupt to event ISR falling. Okay, show results. I counted this many events and loop. If counting, then is time up. If milliseconds minus time is this, then a return. If not, then what the is this. How can if statement have a return? Okay, okay, maybe it's like return. Return is like mean leave this bracket. If it's not, why doesn't he use else? Counting is false and show results. Okay, no interrupts. Start time millis. Clear flag for interrupt 0. Counting true. And interrupts. This is very much what we need. This is very much what we need. Yeah, so maybe we should optimize it along these lines. If the time is up, we display the count. If counting is not currently active, we remember the start time, reset the counter to 0 and start counting up. Code seems to be okay up to 100 kilohertz, although the counts were getting a bit inaccurate. You can do a more precise timings. With timers. Yeah. Prescale. Asynchronous. Prescaler. Oh, this is some serious stuff. I don't know. But something along these lines. I think I'll have to give up on timers and use my other routine. Actually, this one seems simple enough so that I can understand it. This one uses our interrupt and uses milliseconds. Yeah, let's do this. Let's optimize our code here. Timer. And update signal change, that probably will not be used. Instead of update signal change, we will have show results. Yeah, have a good class, Starkey. bless you. How do you LCD? Can you clear a line? Pass counter. So loop should be we could use bool counting. If counting is time up, that's basically what we need here. Start time. And interval. So 1000 milliseconds. Then return. But if not, counting is false and show results. Yeah, that's probably Why does he have counting false here and here counting false true? He doesn't really need it, does he? Well, he does, I guess. We do need it. No interrupts events is 0. So why do we need a no interrupts here? Create a flag for interrupt 0. Why does he need to clear the flag for interrupt 0? No, wait, I can't see this. I don't understand this damn syntactic sugar. Then return, but if not, or in any case, but if not, if time is not up. External interrupt flag register. When an edge or a logic change of pin triggers an interrupt request, interrupt becomes set if the I bit, if the interrupt bit in SREG and the corresponding interrupt enable bit in external interrupt mask set 1, the MCU will jump to the interrupt vector. The flag is cleared when interrupt routine is executed. Alternatively, can be cleared by writing a logical one to it, logical 0 to it. Yeah, I wonder, I don't think we need this. Okay, so counting. So now we need to see how much does it count per pass. I think it was 2 counts per pass. I will check that. Let's connect Arduino. Grab the motor and actually try. Yes, I probably need to verify this. Mode sends const byte sends equals 2. Verify. Yeah, hello Redsock. No green screen. I have rolled up my green screen. I will no longer use it. I have decided no longer to use it because I need the room there. I need the room there for my electronics thing. Events is 0. Yeah, instead of events we need a pass counter, of course. And show results should be here. Show results, yeah. Pass counter. code, and we will use pass counter. Why does it write 83, 87? Mm-hmm. It counts many more passes than I thought it would count. This is not good. Automatically switches to big screen after some time, really? It shouldn't. Yeah, this is bullshit. That really works, yeah, it does work, but it doesn't work in the intended way. I need my old routine back. I need my old routine. but I've overwritten the file. What did we have there? Should have made a backup. Well, I sort of do have a backup if I just watch my old video, right? Check for signal change. And we have signal changed equals true. And then we have pass counter equals pass counter +1, new time, that is that, and I need my old loop. I need my old loop. Basically, we had if signal changed is true, then we want signal changed equals update signal state, and in update signal state we had return false. Okay, update signal state, update signal state, update the counter, and yeah, basically we could here we could have pass counter ++, and then show results basically My old time, my new time. Where are these guys? Where are these old and new times referenced? Update signal state. Ah, here, update signal state. My old time, I see. My new. This is the crucial part. So, update signal. Do I really need these timers now? I just need start time and interval. Pass counter. And then if start time minus interval is less, start time minus with millis minus start time is less than interval or actually is greater than greater or equal than interval, then we just show results, and then we just show results here. So what do you say, Herzog? It could be a source of bugs. It's C++ syntax operator. Yeah, it is C++ syntax. Arduino has C++ syntax. Should not work in C, at least not that way. Global variable to would pass it and return instead pointer or what? I don't know what you're talking about. Is it bad to increase a global variable like this? Why? Show results, and results will show just pass counter and then say pass counter equals 0. Will it work? Signal changed was not declared. Signal changed. Volatile bool. Why is signal change not declared in this scope? It's a global, man. It's a global. What? Ah, single. Okay. Signal changed. Signal changed. Okay, and we need to reset start time, of course. Start time. It is. Are you sure value plus plus really works? Yes, I'm sure. Well, I'm not 100% sure, but I think it does. Wow. What is this? Why does it print this garbage? It looks like it doesn't work. What if I use pass counter equals pass counter plus 1 instead? Signal change. Pass counter plus 1. Doesn't work. Where does this? Where does it get these high numbers from? Where does it get these high numbers from? Maybe it's the falling edge. Maybe I should. I had high here, I know. Doesn't help. Wow, this is so confusing. Where do these big numbers come from? Update signal. Looks like they are changing. I need my old code back. Need to recover my old code because that was at least usable. It was bad, but it was at least usable. So we had So I have to go step by step for this. If signal change true, signal change, then we did nothing but signal changed equals update signal state. Then we had some output on the LCD. Basically, here is where we can say show results. And show results is just show results. Okay. Print line, set cursor, and further up we had check for signal. Okay, this is probably check for signal change, and we still had if digital read sense is true, then we report signal change as true, and if not, then not. Does it make sense? It does, so let's upload it. Yeah, at least it increases the timer every time. It increases the timer twice per pass. It increases the timer twice per pass. That is not what we want. There is something missing. There is something missing here. What if I say it should check for a low? Goodness. And why does it write so many zeros? I see. Maybe we want to change then, instead of this. Okay, maybe then we want high. Why doesn't it no longer work like it worked? There must be a difference I don't know about. Because show results is called every so often. I see. Show results, of course. Yeah, basically. How do you make start time milliseconds? Start time. If counting, we still have counting, right? But counting is probably true in the beginning, so we are counting, but time is not up. Milliseconds minus start time is not greater than the interval. That's why we return. If it is greater than the interval, we say start time equals milliseconds. And of course, yeah, I can see that. And then we need counting through. Three, count is 3, count is 4, count is 5, count is still 5, count is 6, count is still 6, count is 7. Yeah, this works nice. No, this doesn't work nice. Okay, let's set the interval to 10 seconds actually, and see whether it will do the thing we want it to do. Let's wait 10 seconds, it should be 8 again. Two, 3, 5, 6, 7, 8, 9, 10. This is looking good. This is looking good. So let's save it. Dan says, why don't you like the idea of programming games, Nag? It would be a breeze for you, it seems. Oh, not at all, not at all. As you can see, I'm struggling with the most basic things here in programming. If you want to program games, you should be a programming genius. Ah, then you would probably not program games, but really some interesting stuff and get much more money paid for it. You'd be a programming genius. No, but programming games, I have tried really this. If you remember my streams to Counting game, that's basically like programming games. And I have no good ideas for any games. So that's the second thing. One thing is to have the ideas, and another thing is write the code. Okay, so we do have now time. So now I would need to, so this is no longer called, is it? Set cursor to, okay, this is return false. Update state change, new time, my old time. I think this is no longer necessary, to be honest. I think at least this is no longer necessary. It would work just as well without it. Let's try it quickly. It should display 7 now, or 6 or something. 7, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Should display 16. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should display 10. Yeah. 2, 3, 4, 5, 6, 7, 8, 46. That's okay. So it works just as well as we see. And that means the only thing that this thing does is increases the pass counter and returns false. And signal changed false. So we can rewrite it to signal changed is false and pass counter, and let me try this ugly syntactic sugar over here, and it should work just as well. One, two, three, display 3. Yes, 1, 2, 3, 4, 5, 6, 7. It should display 10 now. Okay, my 2, 3, 4, 5, 6, 7, 8, 9. That's now 20. It should display. Yep. Okay, so it works. It works. It works. Good, 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 good. So we don't really need the update signal state thing here at all. But we need to show the results. We need to show the results. And the results, yeah, the results, print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And then we need to set the cursor back and type RPM, and we need to calculate the RPMs. So to calculate the RPMs, we have a count. We have a count. The count is stored in pass counter, and we know the interval. How many seconds? Interval. So if interval is, this is in milliseconds. So if we know that it makes 1 per 1000, so basically interval divided by thousands is the number of seconds. Pass counter, where is it? Display, show results. Okay, so calculate the convert, let's say convert interval to seconds, which is second interval divided by 1000, right? And then we need convert counts to rotations. We need rotations equals counts, actually pass counter divided by passes per rotation. And now we do have rotations per actually this, what if I say interval is 3000, then I have 3 seconds. That's true, 3 seconds interval. If I 3000, then I have interval is, the interval is just the update interval. So let's say I have interval 1000, so I have interval 1 second. So it's just divided by interval, yeah. Rotations divided by interval. Basically RPM equals rotation divided by interval in seconds. And we don't really need these placeholder variables. We can use RPM equals divided by this, and this is what we are going to divide. And I change the interval to one, let's say 3 seconds or 5 seconds. Verify. And RPM is not declared in this scope, of course. Show results. Yeah, show results, RPM. Okay. We don't need the time difference anymore. Do we need old time, new time, and everything? So we can old time, new time. Can say unsigned long RPM equals 0. Verify. My old time, where is it? Yeah, we don't really need this anymore. Upload. Get the console and try. What the serial console writes is count, right? Yes, it's the counter. Okay, let me change to 1 second here. It's better to understand. The display shows now oh, I just only verified, right? I need to upload. So the display shows nothing. It now shows 0. Why doesn't it go back to 0? Why doesn't it go back to 0? Because I think it could be that the pass counter never goes to 0. The pass counter isn't reset anywhere, is that? If signal changed is true, pass counter increases, and if we show the results, counting false and pass counter should go to 0. That's what we need. Okay. So it shows now 0, okay. No, this doesn't work. It somehow is time up. Counting through, and if time is up, if time is not up, it's counting false. Show results, and every time we show results, but every time, why not here? Why can't it be pass counter equals 0? Every time we show results, we should reset the counter. This is very strange. This is very strange. Am I doing something wrong? Why? It would be nice to debug this somehow. I see. If counting is only if time is up. Ah, I see. This reset. Yeah, of course. Only if counting is up, it should this is so stupid syntax. I can't think around this. Why does it have no so if time is not up, just return and do this. But if counting is up, do this. Let's go back to 10 seconds for a while. Let's go back to 10 seconds. And actually, let's have a debugging thing. If signal change is true, then let me please see the pass counter. And if we show result, then let's write result is this. Okay. So it counts. And now what? Result 0. Why is result 0 after 10 seconds? 1, 2, 3, 4, 5, 6. And the result is 0. So why is the result 0? When it comes to the result, it does 0. pass counter passes per rotation divided by interval divided by 1000. Because it's divided by 10, right? 1 divided by 10. Okay, let's say something like float of pass counter and do some float things. So we get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 passes in 10 seconds, so it's like result 0. Ooh, result 0. Come on. Okay, result. Okay, let's see. Yeah, try divided by. I thought it should be in the. It should be. The float should be on in the upper part of the fraction. Is it numerator? Numerator and denominator. So 10 passes. Result 0. Why is it result 0? Do I have something wrong here? The formula is clearly wrong here. Clearly this formula is very wrong. Okay, whatever. I mean, pass counter. Then we say passes per rotation, then interval I need to see what's going on here. Result 0 passes per rotation 2. Damn, why is passes per rotation? Of course, 2. Yes, interval 10,000. Okay. Yeah, passes per rotation is indeed 2. But why the hell is... Oh! Wait, no, I can't. I don't know. But isn't it the variable type? We have unsigned long. Okay, unsigned long is an integer type. So we can float as much as we want. We will never get a float out of it. But at least integer division, where everything is truncated to whole number, it should work. Integer division, damn it. Integer division should work. If I say RPM is like 4 divided by 2, then you better write me a 2 there. It writes me a 0. Ah, you know why? You know why? Because I have result pass counter and I need I need that. Of course, I write pass counter and not RPM, because pass counter, if the time is up, pass counter is reset to 0, and then in show results it show me the 0. That's the whole thing. I'm so stupid. So I need here the previous value of pass counter before it's reset to 0. So I actually need to show results before the counter is reset. Okay, that's it. It should work now. Hey, come on, what do you expected? Something before something? Okay. Let's go 10. Result should be 10. 0. Hey, did we upload it or did we just verify it? Oh, now this is interesting. But now I don't understand it. Now I don't understand it. It's still 0. It is. Oh, there was a result 2 now. Oh, I know. I need a count of at least 20 to get a 1. I see. Yeah, I should get a 1 now. Yes. I should get a 5 now. Oh, 2 now. Yeah, that's correct. It behaves correct. So now that if I, because I should have gone divide by 10,000 here. That's fine. We reduce the interval. We are currently so we have passes per rotation and so many passes. Yeah, because if they have 35 passes, so that is like 17 rotations or 16 rotations, 17 rotations in 10 seconds, which means it's still like 1 rotation per second. So if we change the interval to 1 second again, it should show something more meaningful. if I do only one pass per second, it should show 0. It shows 0. If I do 2 passes per second, it should show 1 rotation. If I go, yeah, so it works now. It works. So now we can connect the motor and try it for real, actually. Yeah, why not use long? I use longs. Long is like double, isn't it? Arduino doesn't have double. Does it? Look, it has data types. It has string, array, bool, boolean, byte, character, float, integer, long, short, string, unsigned, unsigned, long. So it has no double. The integer is already 16 bits. Long is 32 bits. So it's I don't know what a word is. I guess that's some 16-bit unsigned, yeah. Oh, I'll need a short bathroom break, and then we will have a glorious presentation of this thing working. So yeah, he's only calculating full numbers, so it should suffice, right? Yeah, I don't want 554.7 exactly. What I actually would like is like 3 significant digits. That's all I need. It has precision. That's all I ever needed in my life. 3 significant digits if I want to know any number or any value. So yeah, let's connect this somewhere. Yay. This DC motor, actually I must show you the thing here. Wow! It rotates the fan very quickly. Must be careful, and I now need my sensor. What? What happened? It looks like it had no power. It looks like Arduino had absolutely no power when I connected the DC motor. What? Why did it no? Why did it have no power? I have extra power supply module. there a short in that or something? Could be that this motor is actually causing a short. Or if it would be causing a short, it would be affected by it itself. So what's the matter here? Will it cause a short if I have it? So that's not so much of a glorious presentation, is it? Yeah, I have some special cables. So say Kleinvieh macht auch Mist. Ja, oh, look at this. Oh, look at these. Look at these. Look at these. I've got this one with female, male, and male, and I now need female. So female connect to this, and now female connect to motor. Damn it. But it's still, actually this is too bad. I've almost broken my soldering here. But why does it cause, it does cause a shortcut or something. I have no idea why does it cause that. Why does it cause the Arduino shortcut? A short circuit, I mean. And why does the motor run if there is a short circuit? Whatever. It's not whatever. Looks like Arduino doesn't run on oh, I see VSS needs this and this. Oh, okay. Ah, I see. This also needs to go to ground here. And this needs to go to this. That's it. So now we see it. And now I can, okay, well, if it's like this, then yeah, we can see some results here. So clear output. Can't we see the Arduino now? Why can't we see the Arduino on COM8? Is it still on COM8? It's still on COM8. So upload, open console. And how how do I best make this work? I guess I best do this. I really need these wires then. Do I really need them? Yes, I do. Just bought and I already need to break this. But okay. We get 5 volts of it. And I need this connect to this. And this connect to, well, yeah, this. So, and now it doesn't work. Why doesn't it work? Because it's not turned on. Oh yes. Right. We have a DC motor and now I want to see the RPMs. Yeah! That was... what's doing this? What's causing it? Yeah, it's about 100 RPMs. It's not too much, is it? Oh, it's actually RPS what I'm counting. No, wait, is it RPS? It could be RPS, it could be RP second, because we are... Could be, yeah. I think we are actually measuring. What we are measuring here is rotations per second. Passes per rotation. Interval. Wait. Yes, we are. This if we have interval in seconds, and we have some rotations per second, then we have rotation per second and not per minute. So we actually need rotations per minute. And how do we get from milliseconds to minutes? Well, we must float. We must float if we want minutes. If we want minutes, we need floats. Because 1000 somehow, whatever. Interval. Interval is what? Interval is writing interval. No, wait. Interval is 1000. Interval 1000 means interval 1000. Interval 1000 means that only once every 1000 milliseconds we display the result. So interval 1000, interval doesn't actually mean any measurement interval. Well, it sort of does, but it's the update interval. It's the update interval of our display, but it so happens that when there is an update interval of the display, we also reset the counter. So it's also an interval where we reset the counts. And it's always rotations per this interval. So why do I even have this magic number 1000 here? Because there is 1000 milliseconds in 1 second, and I want interval in seconds, and I actually want interval in minutes. So how do I convert this in minutes? I have 1000 milliseconds is 1/60th of a minute, which would be divided by 60,000. And divided by 60,000 as an integer division is always 0. So we definitely need a float, which means RPM must be a float, right? Because what happens if you we could multiply that, but that feels dirty. That feels dirty. But if you multiply the rotations per second by 60, because we are losing a lot by this integer division when counting rotations per second, you know. And I don't want to lose that, so we probably need to cast it to float. And let's say Arduino float. Is there something like float Arduino reference? So you need to add decimal points. Okay, I don't want to. And integer to float conversion or something. That was something I read about denominator or something. You have to use both floats. Okay. Float is the conversion thing. Float data type. Yeah, okay. But what if you, and if we cast float into a, well, I'll try it. 60,000.0, and we make float interval. Wow. Float passes per rotation, and we use float pass counter. And all that will be calculated as a float and then cast into an RPM, which is an integer, so it will be integered again. So let's do that. Let's verify whether this is actually okay to do this. We'll upload this. and we will see if it displays a 0. It displays a 0, and it displays 0 every second. Now I turn on the motor. Put the sensor there. Yeah, that's more like it. 6,000. Yep. Why does it sometimes display 0? Ah! Oh, you can't. I can see what the problem is. Obviously, you don't want to display everything here. This is just pass counter. Okay, let's upload. We don't see this. I don't know what to make out of it. Look at the numbers. Why is it so inconsistent? Now this looks pretty consistent. Okay, there's some serious fail here, and I don't know what it is. Why does it stop? Why does it sometimes stop? Ah, it's my movement here, I see. Yeah, I sometimes, yes, I see that. It's my failure. It's no serious fault. Serious fault is me holding this apparatus. Yeah, it's fine. I was moving. So okay, so we can see that it has about 9,000 RPM. 9,000 RPM, right? Wow, look at the poor propeller. It is all cut down because oh boy, I can buy a new propeller, but I don't need one. Yeah, so this is okay. 9,000 RPM. That sounds an awful lot. That sounds an awful lot. Rotations per minute. $9,000. That's much faster than a car's motor, than a car's engine. Damn it! It's like 9,500 RPM. What we had here, right? Nine six, 9.2, yeah, like 9,500 seems to be 9,400 RPM. 9,400. 9.4 thousand RPM. I can't even imagine such a fast rotation. And if we go back to like 9,400 divided by 60, we are at about 156 rotations per second. But 156 rotations per second, how do you want to? It's so awfully fast. There must be some... I honestly don't believe that it has 100 rotations for 100 full rotations per second. That just doesn't make any sense. It just doesn't make any sense. Maybe there is something wrong with the timing here. Would you? This has never. Can this thing have 10,000 RPM? Can't be. How many volts? Yeah, it's a 5 volts, 5-volt motor. It's just. Yeah, I think it's this motor. But yeah, no load speed, 9,100 to plus or minus 1,800 RPM. So this is actually true. This is actually true. And loaded speed is slightly more. However, the propeller themselves, it's some load. Not so much load, but damn. It's a really fast motor. But okay, so I have to believe it. 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 I do believe it. I want to believe. I want to believe that this has actually so much RPM. It's crazy, isn't it? Let's do it one more time. Of course, this is... What's your damn problem? Why don't you? I think I have a bad contact here. Yeah, but that's okay. Okay. It blows. Good. So this is the RPM meter. So we have discovered what we have read in the specs, that this motor has about around some 9,500 under a little load. That's actually very impressive. So now I need to transmission which would transmission which would, what does a transmission do? Transmission transmits. Transmission translates this 9,000 RPMs to about 1 RPM. 1 RPM and a lot of momentum. Or maybe not 1 RPM, but like 2 RPMs would be good. If it could translate it to 2 RPM. So I need basically a transmission which would 500 to 1 transmission. I need cogs 500 to 1 roughly. Well, I have something to think about. Then I need to take a break for dinner, and probably I will not stream again today. Yeah. Wow. So very impressive. Anyway, thanks for watching, and thanks for assisting me, guys, and explaining me some code. I'll see you again next time.